Good evening, good afternoon, good morning, and welcome to the 18th and final Bitcoin Cash Developers Meeting of 2019 for the public in general. And well, here we are. So I'd like to start off with the introductions all the way around. Start on my top left corner, which doesn't mean anything to you guys, but it would be Jason B. Cox.
Hi, I'm Jason Cox, software engineer contributing to Bitcoin ABC.
And Antony Zegers, please.
Yeah, I'm Antony Zegers. I help out with Bitcoin ABC, and yeah, I'm also known as Mangarian online.
Great, thank you, Antony. Mark Lundeberg, please.
I'm Mark Lundeberg. I'm also helping out a bit with Bitcoin ABC now, and I'm working on this consensus rule upgrade for me.
Great, thank you. Amaury Séchet.
Yeah, that's me. Hello. Okay. I'm the lead developer of Bitcoin ABC.
Good. Chris Troutner.
Hey, I'm Chris Troutner. I work for Bitcoin.com. I am not a full node developer. I play a little higher up on the stack, but I'm honored to be here, and I work closely with full nodes and love interacting with everybody here.
Great. Thank you, Chris. Good to have you here. Josh Green from Bitcoin Verde.
Hi, Josh Green, founder of Bitcoin Verde and Software Verde.
Great. Thank you, Josh. Josh Ellithorpe.
Hey, I'm Josh Ellithorpe. I work on BCHD as well as a couple of other side projects for Bitcoin Cash. Happy to be here.
Great. Thank you. Good to have you. Andrea Suisani.
Hello, I'm Andrea Suisani, a Bitcoin Unlimited developer.
Great, thank you, Andrea. And Tyler Smith.
Hi, I'm Tyler Smith. I work on BCHD and OpenBazaar and some various other Bitcoin Cash related projects.
Great. Thank you very much, Tyler. We're going to, I just want to make sure I didn't miss anybody. I think we've got everybody that's here. Okay, good. We're going to move on to the first item on the agenda is the next upgrade preparedness and the discussion of potential items. There's two left over from last week, or 2 weeks ago. So we'll start with the SigChecks, and who would like to speak to that?
Yeah, I'll speak to that. So yeah, as I understand, I think you guys wanted to talk about that in the last meeting, and I wasn't around. So I'll just give a quick rundown on what the proposal is. So right now there's a SigOps counting thing that we have, and we want to sort of get something nicer. So you don't need to understand how SigOps works because this is just a new mechanism. What you do is when you execute scripts when in transaction inputs, when you're spending UTXOs, when you execute a check sig opcode, you just add one to a counter. When you execute check data sig, you add one to the counter. When you execute check multisig, you add either the number of signatures or the number of public keys, because depending on whether you use the legacy or the Schnorr mechanism can change how many signature checks actually need to be done in the technical details. And then just as one tweak to that, it's possible to successfully execute any of these opcodes and have them return false to the stack if you pass all null signatures. And that's sort of a way of just like bypassing the signature check and saying like, well, no, I don't actually want to sign, but I would like this script to continue going. And in most cases that would result in the script failing because it returns false on the stack, but in some cases you want it to keep going. And so for this case, we've decided, okay, we're just not going to count those because they don't actually consume CPU. And that's basically it. So I've done a lot of research on the historical like blockchain, looking at what kind of patterns there were in the past, and I think we've got a pretty good plan for how to go. And I think I can share the spec I've written pretty soon. So yeah, it's pretty much in a finalized state or polished state, let's say. Yeah. Right. So if you guys have any questions, yeah, let me know.
So, okay, get that closer. I would like to add a few stuff, not really on what the proposal is doing, but what the proposal is for, what problem it is solving.
Sure.
Because I think that's
Oh yeah, I didn't explain that at all.
Yeah.
Why we need this? Yeah.
I think that's of interest because, well, okay, we are amongst developers, so we are interested about the detail because we need to have the full node that are compatible. But what the larger public is going to wonder is, why do I care, and why why the developer are spending that time doing that rather than doing something else? And so it solves a handful of problems, but let's explain what is the current mechanism and what problem does it have, and that should enlighten why we need a new mechanism. So when you validate transaction, when you validate the script in transaction, the cost of doing so is largely dominated by signature check most of the time. And so in the early days of Bitcoin, Satoshi introduced a mechanism that would count the signature in a block, and you would have a limit, a upper limit of how many signature you can do in a block. And that would avoid someone that create a malicious block that have an absurdly large amount of signature, and that is, as a result, absurdly expensive to validate. The main problem with that is that the way it's implemented right now is completely wrong. This is something we inherited from the early days of Bitcoin, and it doesn't count the signature check that happened in the block or that happened in the transaction. It counts the number of signature operation that exists in the block or in the transaction, but that may end up being executed in, like, so for instance, if you have an output of a transaction, in each output of a transaction, there are going to be a signature check if you use like a regular standard address. All those signature check, they count as one SigOps in the block that create them. So if you do a transaction, say if I do a transaction that send money to Mark, there's going to be one SigOps for Mark's address in that transaction, even though as long as Mark doesn't spend it, this signature check operation never happens. And vice versa, when Mark is going to spend that money, no SigOps is going to be counted because technically the operation appears in the block where I send the transaction to Mark. So it's counting the signature operation at the wrong place. And as a result, you can still craft a block specifically by preparing ahead of time a bunch of, getting a bunch of SigOps ready to be executed. You can still craft those very expensive blocks. So it's supposed to protect against certain attacks, but it's not. It's not. It's just making them like slightly weirder and slightly more complicated to execute, but it doesn't prevent anything. A second problem with that is that counting SigOps that way is actually pretty expensive. You want to expect that, but you need to parse every single script, even the script that you don't execute, and do accounting on them. And that's a bunch of operation that the node need to execute when it's validating a block or it's validating a new transaction. That's a bunch of work that is not counting the right stuff. So it's not very useful work. And the more work you do when you validate transaction and block, and the less transaction or the smaller the block needs to be before you run out of resources to validate them. So if we are concerned about scaling, this is something that we need to address. And the third problem is that when we move from 1 megabyte block to larger blocks, we use the proposal that was made by BU at the time that essentially add a chunk of, raise the limit of SigOps, but in steps. So it would allow 20,000 SigOps operation per megabyte rounded up. So if I have a block of 1 megabyte, I can do 20,000 SigOps. If I have a block of 1 megabyte and 1 byte, I can do 40,000 SigOps up to 2 megabyte, and then it's going to be 60,000. And the problem is that this step function creates a very, very strange dual variable optimization problem when constructing a block template, because you can find yourself in the situation where maybe you created the template and your template is now 500 kilobyte in size, but it's already 20K SigOps. So any transaction that you add in that template is going to run over the SigOps limit, and so you cannot do it. But maybe you have actually like 5 megabytes worth of transaction in your mempool. And by the time you add those 5 megabytes, the SigOps limit is much higher. And so you could actually create a block that contain all the transactions that you have in your mempool, except there is no simple algorithm that allow you to know that in the general case. That's a very non-computer science problem. It's especially untractable, and you can use heuristics to try to make it better. But what happens is that someone can always craft a set of transactions, put them in your mempool that's going to defeat those heuristics. So any solution to that problem that use heuristic is actually introducing security flaws in the system. So because the current system is foobarred in so many ways, Satoshi got it wrong when it was counting SigOps, and then BU got it wrong when they adapted that for larger block. The whole stuff is completely wrong from A to Z. And so as a result, Mark came up with a proposal to do it differently, and it's much better, and it's actually counting the right stuff, and it's actually adapting to the block size very much nicely without having this weird step function. And so this is going to be a much better way to do SigOps, and that's why we're doing it.
I would just say one thing. I disagree that the step function is the problem. It's the fact that the limit varies with the block size. I think the same optimization problem would exist if you increase the limit for every 20 bytes, let's say.
Yeah. So we discussed that, and when you increase the limit per byte, you run into some dual optimization problem. They're much simpler than the one with the step function, though.
Yeah. I guess if you wanted to find the perfect optimal solution, it's probably easier. But in terms of like getting stuck the way you describe, you could also, I think, get stuck easily. Maybe more easily.
The major issue with the step function is that maybe you're gonna have to add like 500 transactions or 1,000 transactions before you get back into a state where your block template is valid. So you need to speculatively add into the block template like forever, and there is no clear. And where this is the slope function, it's hard to find an optimal solution, but you don't end up in this kind of situation where you have to, like explore a huge space and you have no idea if any of those, any of those stuff that you're building is leading anywhere. But it's fundamentally the same problem. It's just worse with a step function than with a slope.
Anyway, the problem is going away. We're not doing either of these things because they're both just like, you can see they're going to be annoying. So and there's one other thing I want to add, which is actually the SigOps counting is it sounds simple that you just go through a script and you count the opcodes, but actually that's it's actually not that simple, because what if a script is invalid? You're allowed to have invalid scripts on outputs. What do you do then? And there's something very specific you should do, because invalid scripts go into blocks on outputs. And if you don't count those correctly, then you're not like following consensus properly. And I don't think I actually understand. I'd have to go look at the code again, but it's a mess. So
looking at the code,
the fact that we have multiple implementations means we want something that we can like explain simply. That's not like annoying to implement like it is right now.
Yeah, and another thing I'd like to add is that we've already seen subtle bugs across the different implementations when it comes to SigOp counting. And we've seen inconsistencies between ABC, BU, BCHD. BCHD has basically relied on mimicking the behavior of ABC on all of our SigOps counting just to stay as consistent as possible. So I'm really excited that we're finally looking at this holistically and actually able to get a drafted spec of exactly how this should work. And I think it's going to be really great for all of the different full node implementers. So I'm really excited that this is coming in.
Yeah.
Any more questions for Mark or Amaury on this item? Any more comments? Josh Green.
I had two. So we talked about how we were scaling SigOps, right, per block size. What does that look like? Do we just have a static number, or are we still doing a step function, or is it linear? What is that? And then I'll let you answer. I have a second thing after that.
I'll answer that for now. So the idea is just to make it proportional to the maximum block size. So since you know the maximum block size already, before you start constructing a block template, you know what the limit is that you have to meet. And so because the limit is not variable in the size of the block that you make, it's fairly easy. That's actually what exists, for example, right now in Bitcoin Core. Because they just have 1 megabyte blocks, there's no step function. And there's a fairly easy way to solve the optimization problem, which is it's not a perfect solution, but they have these V bytes. I don't know if you've heard of that, but you basically count either the size of the transaction, or if it's really, really dense in these SigOps, they count the number of SigOps times the multiplier as the effective size of the transaction. And if you just build up the effective sizes of transactions until they hit the limit, you get a pretty decent block. And then you should add some more transactions maybe, because you have a little bit leftover space. It's not perfect, but it'll like fill up quite close to the limit. And on BCH, we don't need perfect.
Yeah, sure. Yeah, and that makes sense. And then to clarify, which I don't think necessarily has bad consequences, but to clarify, that means we could have a megabyte block that has the number of SigOps of 32 or whatever, right?
It sounds a little bit weird, but at the same time, if somebody wants to do that, they could have just padded their block with a bunch of data.
Yeah, you could stuff a block today with a bunch of op return, and
there's no consensus limit on op return size. You can just have a megabyte transaction.
Yeah, I didn't think it was going to be a problem. I just wanted to make sure I understood what we were doing, which sounds like I do. And then the second half of it was, again, this is devil's advocate-y. Is there, I don't think there is, but I'll ask you as a question, is there a reason that we should care about being able to count the number of SigOps in a script without actually having to execute it? Do we get anything from that property?
It is nice to be able to do that in some cases, for sure. So that property is going to be semi-lost. So, okay, for the purpose of wallets, they won't really care because the limits that are going to be in place, they're not going to affect regular operations. They're going to be quite permissive. What it would affect is some really weird smart contracts that are sort of intentionally inflating the CPU usage. So if you were doing that, you would have to know by executing the script or the way you designed it, how many SigChecks there are. And internally for the implementation of the node, maybe there are some circumstances where you want to know how many signature checks there are without doing the signature checks, right? Because that is expensive. So the way it's specified actually does allow you to, you can actually run a script through and not do any of the signature checks. You just you look at what the signature is, if it's null or not null, and you can actually skip over the signature checks and continue executing the script. And you'll have all the correct return values. So you can sort of just, bypass that. So you can do a fast execution of the script and count those SigChecks that way. The current design allows for that. That's why we did a certain thing with the multi-sig. If you read the spec and you're wondering, you'll see.
And I think that's possible because we have the sig out thing, right? If you provide a signature that doesn't pass and it wasn't null, then I think we fail the script.
Yeah, the null fail rule.
Yeah, the null fail. That's what we call it. So with that property and in conjunction with the fact that we can then tell, we can actually skip it if we don't want to. I mean, full nodes shouldn't, but could in some circumstances. So that makes sense.
If I understand correctly, Mark, that's why I think the specification you wrote says that if the signatures are null, you don't count SigChecks, right? So that means that normally it would fail in those cases, but for like a 0 of n multi-sig, that would also make it be 0, a count of 0, I guess, right?
Yes, yeah. So that's one of the funny things about multi-sig is you can do 0 of whatever, and it's funny. It's funny how much this is this weird edge case that is kind of stupid. It's funny how much this is influenced the way we look at designing multi-sig and the Schnorr multi-sig and all these things. spent hours and hours agonizing over this stupid edge case, but yeah.
Yeah,
I think we
what
figured it out.
happened, like, is a 0.0 multisig correct? Like, always true, always false? And
Always
how does
true,
it
yeah.
fit in the overall model? It's always true right now, if I'm not mistaken, but I'm not even sure. Like, there is a ton of very weird edge cases like that make zero sense whatsoever.
I also wanted to comment or maybe ask a question on Josh's previous question, which is I'm just thinking about in the future when we hopefully move to adaptive block size limit. So that would mean that SigChecks limit would also be like tied to that limit, right? So that's something to keep in mind. Maybe I don't know if that affects how it's implemented or not, but
it floats in conjunction. Like, it's essentially it's a SigOps density depending on the maximum block size.
Right. Okay. Yeah, that makes sense. Just wanted to confirm that.
I didn't mention, but I should also point out, so besides the block limit, we also want to have a standardness rule that gets activated at the same time, just to limit what happens in the mempool, to make that reasonable. That you can't put like a 1 kilobyte transaction that takes 1 second to validate or something crazy like that in the mempool, because probably nobody's going to want to mine that anyways, that kind of ridiculous abusive transaction.
So is the standardness one going to be based on input density?
Yeah, so you make an allowance for the number of signature checks based on the size of the input. And the size of the input is basically it's like an offset plus the size of the script sig, the unlocking script. So we just use the unlocking script length and make a rule based on that.
Okay.
Yeah.
So any further questions or comments? We'll move on to the next item, which is, of course, other items. What are the other potential items for upgrade preparedness?
I guess I could talk about script stuff, although it's not really specific to this coming upgrade, because I don't know if there will be anything ready for this upgrade or not, but we had a meeting last week, which is online, so people can watch that, which was basically like talking about all the different proposals and kind of just spitballing different ideas and things. So I'm at this stage where I'm trying to write all those ideas down in a kind of comprehensive, I guess, sort of roadmap or plan with design goals and use cases and stuff like that for the overall plan. So I'm still working on putting that together, but I'll try to pass that by everyone in this group to get feedback and so on. So yeah, that's what I'm working on.
I'm curious, what was your sense if we could just pick one thing that's small and try to get that in for this upgrade? If there was one thing like that, what would it be, would you say? One item.
I don't know. I mean, probably just adding an opcode or something, like whichever one. It seemed like up reverse is wanted.
That's a very easy one, for sure.
The other one that it seems like everyone agrees that we want to do, but it might take longer, is increasing the size of integers, so that they're not 32 bits or whatever they are now. Yeah.
Yeah, I was thinking a little bit about implementing that. Like how hard or easy would it be? I don't think it would be that hard. It should be all right.
I think
from the application developer level, I would second the op reverse if it's easy to get in, because I know that some of the script developers I've talked to really wrestle with the endianness. So if there was an easy opcode to make that easy, then I think there'd be a lot of value there.
Is that only for SLP that you've heard that in the context of, or other applications also? Because
mostly SLP, but not exclusively SLP.
So some Oracle applications maybe that.
If you could actually, I should get in touch with you, Chris, because if you actually have like a list or some other use cases, that would be good to know about to add into what I'm writing.
That's not
if the Indianness or op reverse, if that's being seriously considered, then I can reach out to some of the application developers and yeah, just be like, hey, give me use cases for why we should do this sooner rather than later.
Yeah, I would like to see those use cases. I asked for them in the last meeting, and I don't have any off the top of my head other than SLP at the moment.
Yeah, it's good to have Chris here so he can see what he can do to bring it along. Is there enough time to make some of these changes and do the testing before May?
Well, yeah, I would say like op reverse is quite easy if we really wanted to do that. We could do it now if we knew that we were like, if we knew that down the road we wanted to do that anyways, it wouldn't be that hard to, I think. The only question is like, you probably want a limit on the size of the thing that you can reverse because the execution time is linear. So you don't want to introduce like a quadratic abuse vector, basically. So maybe limit it to 32 bytes or something. I don't know.
Okay,
it's
thanks,
not
Mark.
complicated.
I was just gonna say, I mean, I don't know about the timeline, but we may as well try to assemble information and move forward. And if it doesn't make it in this upgrade, then maybe it'll go in the next one. So,
Yeah, that makes sense. Because we can start scoping these things, and if it does land, then it's mature, then we make sure it gets included. Otherwise, maybe it just doesn't make it for this particular upgrade. I don't know any of these use cases for op reverse directly, so I'd be curious to see what those are as well. But implementation of it's pretty easy, and as Mark pointed out, it's pretty easy for us to put limits on what can be reversed, so people aren't reversing, gigantic data sets.
Great, thank you, Josh. Any further comments?
I know, so we talked, it's a shame that Tobias is not here today, because I think he was advocating for OP reverse. He was also advocating for increasing the opcode count for scripts, if I recall correctly. I think we put the onus on him to try to prove up some basically show the support or show the demand so that we can support it. And I don't know if he's done that or not because he's not here, so we can see that for sure one way or the other. But I know that a lot of the discussion revolved around the last time was we wish Mark was here because and even Amaury or somebody sharing their thoughts on the significance or insignificance of increasing the op limit. Because I don't think we were really able to identify anything that's blatantly bad about it.
Yeah, this ended up getting discussed in more detail, in that script meeting. So the big question that it raises actually is about there are some opcodes that execute in a rather long time, like a linear time. And so if you can pack more of them into a script, that's sort of like a quadratic growth in the execution time. Well, it's actually just linear in the new variable that you're doing, maybe, but it's not ideal to introduce new abuse vectors with these long-running opcodes.
A few of them are actually quadratic.
Like properly quadratic in the number of opcodes, or?
Well, there is the if one that is that execute in a time that depend on the depths, like how many nested if that you have. So if you make a bigger script, you can put more if in there, and you can make them more nested, right? So this is gonna grow quadratically. Someone that want to do these kind of things, and you have computing sig hash in conjunction with opcode separator that is also quadratic.
I think these are both governed by the length of the script times the number of opcodes that you're allowed to execute in the script. I think that's a scaling rule for both of those. Because for the op if one, you do op if down to really deep nesting. I think you do a false branch, and then you do a bunch of op null zeros inside the unexecuted branch. And each op zero takes forever because you have to go through the whole if stack. And that one actually that's an implementation detail that it's slow. There's an easy workaround.
This one is probably fixable.
It's very fixable. I think the only reason it's not fixed is people are scared to touch the consensus code, and rightly so. You know, like, but the fix is known, right?
I think that there is a bit of a more general problem here, is that the whole script system imposes a cost on everybody when you run a script, and there is a bit of a tragedy of the common problem here. So we can increase the size of the script, but there is always someone that's going to want to have a bigger script. And it's not clear to me what should be the process to decide what the right size or what the limit should be. But I think we should probably try to come up with use cases and see, you know, what kind of use cases we can have or we cannot have with specific numbers, and see then, you know, like if we as a community are okay with paying a little more in terms of resources to validate stuff to get those use cases or not. And it's obviously going to depend on the use cases. I think this is the only fair way to try to come up with a number. I would like also to point something. There is something that has been known for a long time, but has been painfully unexplored, and that may be an escape hatch to that tragedy of the common problem. It's zero knowledge contingent payment. So zero knowledge contingent payment is a way for two parties. So basically what a script does is that it's a predicate. So a function that takes an arbitrary number of parameters and that returns 0, 1 at the end. Yes, you can spend the coins, or no, you cannot spend the coin. And if you can provide the right answer to that question that this predicate is asking, then you can spend the coin. And zero knowledge contingent payment is a way for two parties to play that game between each other and have a very, very, very simple contract that is on-chain that can verify that this game has been played between the two players correctly. And the general idea is that the two players are going to agree on some contract, just like they do right now with addresses on-chain. And one party is like the party that want to spend is going to have to generate input for that contract that generate 1 for the predicate. And that party is also going to encrypt those parameters and give it to the other party. Like, here is an encrypted solution to the spend. And here is the hash of the key. And here is a zero knowledge proof that it's all check out. It's all, you know, what I'm pretending it to be. So the other party can verify that those input exists, the coins could be spent, but has zero information about what those input are going to be. And then the other party can do a contract that is on-chain that require posting the encryption key essentially to unlock the contract. So it's like a regular signature check plus a pre-image check. So that's very cheap. And you do that on-chain. And by acquiring the coin, the person that wants to spend, by acquiring the coin on-chain, it has to publish the encryption key of the solution. So the party that wanted the parameters to the predicate can have those parameters to predicate. So that essentially achieved the same property as the on-chain script that we have right now. Though, because it's not that much explored, it's not quite clear what the performance characteristics are. And so it's not quite clear what kinds of use case can actually use that and what kinds of use case cannot reuse that because it would be absurdly expensive. So yeah, some people have made toy example in the history of Bitcoin, but nobody has explored that seriously. And I think we should probably do that because if we can make that work, if that indeed work and that works well, that means we can deploy any kind of script system that we want. Right, you know, like have any system or smart contract, and only the two parties that want to have a contract between themselves need to agree on what this smart contract system needs to be. And none of that require any consensus layer change. If people want to use another smart contract technology tomorrow, they can, and they don't need anything to happen on chain for that. So like the upside, if we can make that work, the upside is pretty big. And it also obviate this whole, you know, like what do we want in script, or can we change the script? Maybe we can increase the opcode limit or whatever. Like all those questions also become obsolete if we can make that work. So, so I think this is something we should look into.
This is something I've been looking into the past few weeks, actually. I certainly am not far enough along to have anything to share, but I agree with Amaury. I think this is a really interesting and has a lot of potential way to go. So I think I agree that if other people are interested, I would love to work on this. So I think we should try to push this forward if anybody else would like to.
Yeah, I mean, honestly, I agree with both points from Amaury. First is, if we're going to extend the script limit in any capacity, we need to know exactly why and how that makes it function as better cache, and understanding what the use cases are so that we're doing it intelligently. But I actually really love the idea of being able to do this with zero-knowledge proofs and not having to do this all on-chain. You get better privacy characteristics as to what the contract was, and it has a lot of benefits. But it's relatively new, and it seems that since it's just somewhat unexplored, I don't know what the time frame for doing what I consider a major change like that, even though I think that that's a really good idea. So for the time being, if we need information about not only the use cases they want for the larger script size, but a better estimate as to the work required for us to do a new approach and what kind of time frames we're looking at, and really debating what is the better solution. You know, do we start working on a new way to do these that makes the script limit, irrelevant, but if that takes 2 years, then there might be a reason that a small bump to the script limit may be required for use cases that are deemed good for peer-to-peer cache. So I think that more information gathering is kind of in order for us to make a good decision as to which approach to take.
Speaking of information gathering, Amaury, what is the relationship between what you just described and ZK snarks and these other kind of keywords that have been floating around in the crypto space for some time? Are they all kind of the same base technology with a different name, or is it something else?
Well, it can use ZK snark, you can use Starks, you can use like whatever zero-knowledge technology. It's off-chain, right? So you don't need to
So those are implementation details, or?
Yeah. You only need to have the two-party that contract with. Like, I don't know why my camera is blurry now. You don't need to have everybody agree on a single technology there. You just need to have the people that want to contract with each other to agree on something. So if they want to use ZK snark, they use ZK snark. That's great. If they want to use anything else like bulletproof or Stark or whatever other zero-knowledge proof technology, they can use that as well. It's no problem.
Yeah, on a similar note, I've had a similar idea of offloading the script on chain by using like IPFS, where the immutable, like whatever script is stored on IPFS, and you get that immutable hash to retrieve it, that could be written on chain, and then whatever protocol you develop would know to like, okay, we agree that this is the hash of the program that we're going to run. And then, like Amaury said, that thing runs and it comes back, and we use object data sig. It either passes or it fails. And it doesn't require zero-knowledge proof at all.
Yeah, I think that sounds like largely like pay-to-script hash with like a distribution mechanism for the redeem scripts, which is an interesting idea. I've not thought about that before.
On this topic, I had a question for like the collective knowledge here. Is anyone aware of a script that maximizes execution time? And the reason I'm asking is, like, when we were developing the validator for the simple ledger protocol, every time like a bad transaction that came through and messed up our validator, like we saw it, we added it to a JSON file. And so we just have this really nice collection of problematic transactions that we run against the validator every time. And I'm thinking, like, if there was a script that maximized execution time for a miner, then that would kind of give us a feel for, like, okay, if we expand the number of opcodes, then then this script gets bigger, and we can measure like how much more execution abuse is possible.
Oh yeah, those examples we discussed with the up if thing. You can sort of imagine extending these. There's one involving up roll that's annoying, and there's this up code separator thing.
There is some pretty bad stuff that you can do with a combination of check multisig, and you do like check multisig 1 out of 15, for instance, right? And you publish what is what is a valid public key, but you have no idea what's the private key associated is, by using like num2bin and cat and this kind of operation to just like expand a bunch of garbage public key, except the last one, for which you're going to publish an actual signature, right? So you need to do 15 signature check. And if you do those kind of operation repeatedly and have code separator in between them, you need to recompute the sig hash. And so you have to compute the sig hash that depend on the whole size of the stuff, do 15 signature check, opcode separator, and you do it again. You can do pretty expensive stuff that way. There are various constructs that are expensive in various ways.
That also might be something that we can kick to the script community and say, hey guys, in order for us to get better data as to the maximum runtime based on script size, I want you to craft what you think is the most expensive fucking thing we can run. And then we can figure out what the exact numbers are. I'm sure somebody would have a little bit of fun figuring out what that is. And it doesn't have to be one of us.
I would like to point out this should be done on testnet.
Of course.
Well, yeah, actually,
you say of course, but there's plenty of people online that don't agree with you.
Yeah, well, you probably won't. The worst abuses actually usually involve non-standard scripts that are like long script pub keys, the full 10 kilobyte limit that you can't do on mainnet anyways. So unless you're a miner, yeah. So
it's
just
that's an important constraint. I would restrict it to standard a standard transaction that maximizes execution.
Yeah. So those are much milder because it's usually paid as script hash, only 520 bytes, etc. Yeah,
but I'm thinking that Tobias or Roscoe could probably put something together in cache script pretty easily to see, like how do we max this out? And then we can figure out, what we think are reasonable performance requirements per block. And we can get to a point where we actually know whether or not it's going to be safe for the network. I'm always on the side of more data to figure out what the best safety operations are.
I think that's also a really cool idea. And it's also plays on the theory of like white box, black box, testing. Because like Tobias, while super savvy with scripting, he doesn't really know implementation details. He just knows the opcodes. So like he doesn't like what might seem expensive from his perspective might actually not be expensive, and vice versa. So I think if we as a community came together and did something like that, that might be very valuable. And on that same note, speaking of value, Chris, if it's possible, open source that list of bad transactions. That would be cool. I would love to run that against Bitcoin Verde because, like, especially for a lot of those things, like they don't get relayed, right? They're bad. So we have a bunch of positive tests where it's like this should be valid because it was included in a block, and then this shouldn't be valid is a little bit hard to actually be exposed to because if they're not valid, people don't relay them. So having that data set, I know we have some already, and it's great. Having more of it would be awesome. So if you think it makes sense and you can do it, I would love to have it.
So it's also a point that how much execution is required before you know it is not valid. So if somebody is poisoning a node with a bunch of transactions that take, a bunch of time before you know that it's invalid, guess what? That's still an attack on the network. So I think that we should also be paying attention. Like, yeah, I agree that we should do the standardness ones, but we should also understand, if someone sends a bad transaction, what are the largest bad transactions that actually cost validation time?
They're pretty much the same. And here is the reason why. You can take any expensive correct transaction and add an op-nup at the end of the
Oh, that's true. Yeah, okay.
you get something that you only detect at the end that it's invalid, and
Perfect.
And then you don't even ban
Those
the
are
node
the same,
because it's non-standard. Yeah.
Okay, guys, are we done with that part of things, or are we ready to move on to Josh Green's specification update for Bitcoin Cash?
I'd like to add one thing about the whole series of transactions. So I'm also pretty interested in that. I think the best way to go at it is to use the same format. So in Bitcoin ABC, there is script.json or script_test.json or whatever. There is a file like that in RSRC test data. There is a script something.json. And in there is a bunch of script, interestingly, that either pass or don't pass depending on various parameter. And if they pass, they tell you, they tell you that they pass. And if they don't pass, the JSON file tell you what error you should get. And I know that many other people, and this is why this file is for. This file is for, it's in JSON, so it's very inconvenient for us to do it that way, to be honest. But the reason why it's in JSON is because everybody can take that file and use it in other node implementation to test for compatibility. So if
BCHD actually uses those script test vectors directly to make sure that we're compatible. And I encourage everybody to be using those. There's a reason we have a JSON file with this is good and this is bad. And it makes it easier for us to stay in sync when we see new bad or questionable transactions on the network. All of a sudden, we have a single place where we can add additional vectors and make sure that everybody's compatible.
Yeah, so because people have cut to decode the JSON in that specific format, it would be absolutely awesome to get the list of like crappy transactions that you've found out in that specific format.
Yeah,
SLP has
transactions. I can read the hex with my just my eyes and get the script out of it. It's easy. No, I'm not that good, but I can convert the bad transactions to script tests. I'm quite familiar with that system.
I thought you said hex there for a second. Chris, did you say something about that?
I was just going to say SLP has the exact same thing. It's a JSON file of good and bad transactions. So I will try to ping with you, Amaury, and get a link to that JSON file. And I'll also locate the SLP JSON file. And I'll send a link to Josh Green so that he has both of them. Might be good to reference in the implementation.
I'm going to search for it right now.
Okay, and you guys will communicate well. And if it shows up in the show notes, I can make sure that gets out with the video of this meeting a little bit later. Anything further on these wonderful topics before I turn it over to Josh Green? No? Then without any further ado, we'll move on to the BCH specification update from Josh Green. Thanks.
Yeah, so things have been going very well. We've actually, as of like last night, opened it up to like what I would call the like business equivalent to like a private beta. So asked some of the other collaborators of the other node implementations to start putting in contributions if they feel the desire to. Which is a kind of a big step because that basically means that we've gotten a fairly healthy like precedent set, a tone set, style guide, some other like meta stuff, and ultimately a structure. We also have an organizational tool going, which is probably everyone's used Trello, but we have a Trello board that's open that just allows us to collaborate a bit more, so that way we're not stepping on each other's toes. So I expect like the progress on the actual content to be improved quite a bit. Much faster than what we have been. Getting started was a little bit slow, but we knew that was going to be the case. I think I'll kind of rehash the things that we talked about last time as far as the direction that we were planning on taking to make sure that just more exposure and with the different audience too. So we're trying to make sure that every implementation has our own space in every section to say, hey, this is what we do differently, which allows the standard procedure to be very, very well defined, which is every node does this. If every node does this and it is like the gross supermajority, then that is what standard or the spec is, right? So we're taking like a descriptive approach, not necessarily a proscriptive approach saying every node implementation must do this. We're actually saying every implementation does this except for X, Y, and Z if they choose to call that out. And that's because the spec doesn't really have authority, right? Like we can write whatever we want. Anyone can write whatever they want, but that's not necessarily reality. So we don't want to pretend like we're masquerading as some authority when the reality is we're just trying to document the behavior as best as we can for other collaborators and also people who are not necessarily in the weeds of node implementation. So with that, we're also trying to make sure that we're very objective and factual. So there is not meant to be a tone in which you're writing. Nothing is opinionated, and even to the point of like the concept of we should emphasizing bad behavior, right, is actually something that we specifically don't allow. So it'd be improper to say, nodes should do this or should do that. The reality is we're actually just describing what people are doing. And that just avoids a lot of conflict and makes everything very easy to handle as far as people disagreeing with the direction, and keeps the content just much more accurate and much less political. On top of that, it's still meant to be clonable, and so we're going to have like all the data is stored as Markdown files. So on a public GitHub, or repo, however you want to store it and distribute it. So that means if you want to fork and have your own copy, you can. For instance, we're going to set up a protocol.bitcoinverde.org, and we're going to run a clone of whatever documentation we have. There's going to be a core distribution, which we're still debating on the URL. I think one of the we're still deciding on what that URL is going to be, but we're trying to keep that pretty distributed as much as possible so that we don't have another like Blockstream situation where they control what everyone sees. And ABC can run their own version, BU can run their own version, and it's basically just true to the mentality that this is a descriptive document, and we're just trying to do our best to document it. With that, we're probably about maybe half of our allocated budget that was sponsored by BU. Which is awesome that they were able to even do that, because without that we wouldn't be able to dedicate our full time to it. Obviously, we were looking for follow-up opportunities and funding to dedicate more time. But I think at the end of this installment, we should have enough content that it's valuable to the greater community. It's obviously not going to be as valuable as the collection of data sources, but at least it's got a lot of the good parts of everything. So I call that kind of like a critical mass, where it's just useful for people to use, and that's ultimately what we're going for, because then we can allow, or it'll just facilitate people to continue to contribute and make minor updates. So happy to answer questions, but as far as that, it's kind of the update.
Thank you, Josh. Do we have any questions, you guys? Yes, Mark?
Yeah, I'm just sort of wondering, I think I sort of understand, but I'm just curious to hear you say it so everybody can hear. What is the final, what do you envision the final, the final state of the system? What's that going to be like when that's all polished and in the public and stabilized and everything? As compared to, say, like the Bitcoin wiki, or compared to the Bitcoin Cash org, the GitHub specs for the forks, in comparison to those things, how does that look like?
Yeah, I'm assuming at that point you kind of mean like I want to call it like almost the architecture of it. Are you talking like, are you talking about specifically the content? Because those are two different emphases.
Yeah, so like kind of the content, but also the I don't know, like how accessible is it for people to edit? Yeah. Like, is it totally open for anyone who gets an account, like Bitcoin Wiki, or is it more closed?
Yeah. So that's a great question. I touched on that briefly last time. I'm happy to expand on it here too. So the way that we're kind of architecting it is going to firstly be completely dependent upon the hosted, the hosting provider, right? Like ABC can take the content, the markdown. They can fork their own repo and then display that however they want, right? Like they can make whatever rules they want. They can open that up to whatever accessibility, they can open it to the whole world if they wanted to. Whether or not that's a good idea, I can give you my personal opinion, but ultimately it's your decision. And what we're picturing for the coalition, right? So the coalition is like a representative from every node implement, except for Flowy currently. I think we have a representative from everybody except for Flowy, and we've talked to the guys from Flowy. I just think that they're too busy, and legitimately too busy. Not that they don't care. So that coalition, I think we're going to all try to distribute that, what little tiny power that has, so that one person has the domain, one person has the server, one person has the super admin account, like those kinds of things, so that it's at least hard for us to become tyrannistic, and definitely ineffective. But what that would look like is those representatives from each node implementation would be granted access, and from there they can live edit things, and that ends up getting published to its own. Each user has its own copy in a repo, because everything's stored by through a Git account. I think it's actually a Git directory on the server. Every user has that, so they can publish and make their own commits, and then they can publish it to the rest of the world, and then each user on that forum can, including the anonymous user, which is what the public users see, they can see that content live as it's edited. If there's a conflict, you can resolve the conflict, and if people disagree, then we're just going to have to be, adults about it, because there's no current voting mechanism to say what is true. That's why setting the precedents has been so important. We think that we've come up with enough set of rules around what is the intent behind the document to say that this is either a fact or it's not, so there really isn't a whole lot of room to disagree. And that ultimately should be the deciding factor for what the content should be. And then if they and they are super salty about it and want to go do their own thing, they still can, right? They can take their changes that they made from the repo and they can go post their own version. They can make that the the publicly accessible anonymous account and do what they would like. So ultimately, we are giving ourselves enough of an opportunity to be collaborative and really make the community, provide a service that the community needs. We're also giving people the freedom to disagree, which is the whole point of this. So by this, I mean Bitcoin. It's the whole point of Bitcoin, right? People are allowed to disagree. And that's the mentality that we're taking from a content perspective. So let me know if that doesn't answer your question.
Everybody disagree on that?
I think I get it. Yeah, I'm curious how if there are 10 different repos, how are they all gonna slowly merge back together so they don't just diverge forever, right?
Yeah,
so it's gonna involve some manual Git merges of the histories, or there's people copying stuff over. I don't know what that's going to take.
Yeah, it depends on how they're using the. It depends on how they're using the system, right? If ideally, in a perfect world, the coalition version is where most people want to go to read and publish updates, right? That's where they want to go. They might have their own individual copy that's basically just a, its origin is the coalition. So when there's an update, they just pull it themselves whenever they want. And then, protocol.bitcoinverde.org gets updated when the coalition's version gets updated. And that's up to bitcoinverde.org to decide on, when they go. But when someone wants to make an update, they go to, the coalition version, right? They go there and they say, okay, I'm going to look at the content. I know that that's the most fresh version. So I'm going to change this small thing. And then it'll propagate down to, my individual version. And that's kind of like the flow as it would distribute itself. It wouldn't necessarily be pulling in ABC's protocol version or anything like that. Now it could, And that's also a cool part of it is, if they have their own system and they just want to make a pull request, or if, we get access to the commit in any way, like you can still just pull things in just like you would normal source code. That's kind of, up to the individual maintainers to decide when and how that happens.
Thanks, Josh. I just noticed that Josh Ellithorpe, I think he may have already left. I wanted to give him a chance to say something before he left, but I guess I missed the window. Anybody else want to comment on the specification or ask questions about the specification update?
So is the medium for the specification, is it going to be on GitHub or a different platform?
Do you mean like the way that people consume it, like an average person reading it?
Yeah.
Yeah, that's going to be like for the coalition idea. It's kind of in the air for what that's going to look like. It's going to almost certainly be a website of some kind. It's not going to be the GitHub, and the reason is because with just a pure GitHub tool, like it's a bad user experience to make small updates, right? Like if you are in there in the script execution for an opcode and you're like, oh, this is wrong. Or even if you're there as, a representative of one of the node implementations, say, oh, I do something differently, or, nuanced, how easy it is for me to include my own documentation for what, I do differently. From a pure GitHub perspective, that is not the easiest for a couple of reasons that I don't really have to explain. So what we wanted to have is like a wiki like experience where it's like, oh, there's something wrong here. I will edit it, and then I will edit it through the web page, save it, and there it is. So we're using a tool that effectively does that. It's complicated and does some cool things, but from the user's perspective, it's a wiki from a user's perspective. Yeah, does that answer your question?
Yeah, that makes sense. And I can also see how that ties in with the historical way that the sort of attempts at nailing down a spec has been done in the past. I'll just say that for Simple Ledger, we use GitHub for that, and it's worked pretty good because we can use like an issue to discuss changes to the protocol, and then I really just love that whole version control and like get blame. Like if you're like if you check the spec and it's different than what you remember, you can be like, what? And check the history and see like who committed what. So I can see it both ways. It's really just a matter of preference.
Yeah, no, absolutely. And that's why having it being backed by Git and having it backed ultimately like the database, which is the collection of markdown files, right, are on a public Git repo. So you can still do that workflow of like, hey, like I have this commit. It might be controversial. Let's have a discussion on it. We can still have that on the database itself, right? And that's a great way to also facilitate people who like your I don't want to say random Joe, but it could essentially be your random Joe, right? You're just miscellaneous person who's like, hey, I want to make an update to this, but they're not going to have an account. And we're doing that to help mitigate certain trolling behavior. So if they want to take the time to like contribute to the specification, then they do that normally just through a Git pull request. It's a little bit of a degraded experience, but it's still not silencing somebody. It still gives them a voice, and it also gives us the tooling to kind of vet their intention. So we're hoping we get the best of both worlds. We're optimistic. I think it'll work. So
that's
thanks.
Great, Josh. I think that there's a lot of optimism around the work that you're doing from all the different groups and what I've heard. I do want to make sure that Tyler Smith gets a chance this meeting. So if we're done with the discussion on the specification update, we put off for two meetings now the Avalanche discussion. Tyler, are you ready to go at this?
Yeah, I mean, there's honestly not a whole lot of update. Unfortunately, I haven't had as much time to work on it recently as I would like. I've made some significant improvements to the code and gotten the spec fairly decent. None of it's really to where I wanted it to be before I made it public, but at this point, in the interest of getting something out there, I am just going to put up what I have of the spec and the code online, and I will post a link to that in the Avalanche working group on Telegram later today. So like I said, it's not, if you're interested in coming and reading the final spec and seeing exactly how it's all going to work, now's not the time. But if you want to see what is there, start commenting on like the core system I have described. It's probably going to be meaningless if you don't already have a decent idea of kind of what's going on at this point. But that's the kind of thing that I want to improve going forward. But it will at least be public, so anyone that has interest can see where it's at. So,
and Tyler, you had no shortage of people telling you it's just not going to work. Is that correct?
That would be accurate. Yeah. Okay. We'll see. I mean, it remains to be seen.
For sure.
Yeah.
I'm just saying that this is the problem with the early days, is that you don't always get the openness to the possibilities of things. So.
Yeah, definitely.
Great. Anybody have any questions for Tyler?
Well, be a comment. I'd love to join that Telegram group. So let's make sure that you get the links to David put in the show notes or pass it along to me.
I'll post them. Yeah, I'll post them in the chat right now.
That's great. Thank you very much, Tyler. We're rounding up to about an hour and a quarter so far, and we don't have anything specific on the agenda now. Is there anything that anybody in this group would like to bring forward that has not yet been discussed?
I was trying to get to my mic. There's a couple things that I thought I just mentioned, kind of food for thought since everybody's here. The first is that there seems to be a growing, I've had a series of discussions with application developers on extending the number of op returns. There seems to be a lot of interest, and in the discussions that I've had, the right number that people seem to get, that we seem to achieve consensus on, is 3. 2's not enough. It's hard to make a business case that 4 is better than 3, and everybody I've talked to has a slightly different viewpoint. But what I don't have at this point is theoretically and I realize that this is not a consensus change. This is like a non-standard. It's kind of up to the miners, is my vague understanding of this. But if it was 3 and no other rules were changed, what would the sort of the implications be at the level of the full node and sort of what, like, I understand it from like an application standpoint. I don't really understand it from like the perspective of a full node developer. And then the second thing that I thought maybe we could just bring awareness to is this, we've been seeing 0 fee transactions. I've already talked to Mark and Amaury about this a little bit. We've seen 0 fee transactions get accepted by full nodes when the UTXO is old. And by old, I mean like 1,000 confirmations. And so it seems to be that this is just a thing that exists and it needs to be addressed, but it's not a huge issue. And given the lack of funding and manpower, it's just not a hair on fire problem. But
fix that already.
Oh, did you?
Well, it'll be fixed in the next ABC. Yeah, there's a weird bug. Yeah.
So yeah, I'd like to talk to that one because I think it's an interesting problem. So doing free transaction when UTXOs that are being spent are pretty old is something we've been wanting to do since pretty much the beginning of BCH. And the main reason is that the reason why we have fees is to prevent someone from bloating the blockchain, like blowing the size of the blockchain out of proportion. But old UTXO are like pretty much by definition scarce, right? Because you need time to produce them, and time is scarce. And therefore you already spend a scarce resource to produce that UTXO that you're gonna spend. And so there is not really a point having the person to spend another scarce resource like BCH themselves as a fee to do that. So someone, I think it was SigPig, actually, Andrea, who was here, if I remember correctly. Like more than 2 years ago, started working on that. The problem is that it never really got in a stage where it was actually working very well. And there was discrepancy between what the RPC is doing and between what the network layer is doing and all of that. And so, yeah, this is what you run into, and this is what Mark fixed. But this speaks to the fact that this is something we've been talking a lot informally on the internet lately, but this speaks to the fact that you cannot just like put some code out there and expect it to work forever. We need like for every single feature and piece of code, we need someone to basically own it and like take care of it and keep it, keep it in a good shape. And it's maintenance work. And the problem with that feature and why it ran into problem is that we don't really have someone that is owning that and taking care of it. And, that's an ongoing problem, especially in the bear market. Like, in the bull market, you can hire a bunch of people to do that, but in the bear market, that's not the same. So this is something that people need to keep in mind, because often people are asking like a bunch of stuff and they're like, okay, why wouldn't you do that? And even sometimes the code change to do the actual stuff is not that big, but we need someone that is around that's going to take care of it, or the kind of problem that you run into is going to happen. So that's it. On the
Definitely.
On the issue itself specifically, Mark worked on it recently. And so it should be fixed in the next version of ABC. For the up return specifically, up return is kind of weird to begin with. It's kind of like something that was not really planned into the protocol, and as a result, it's an output of the transaction, but it's not really an output actually. It's like some data that you attach to the transaction, but it's encoded as an output. So you have some weird script in there and an amount and a bunch of other stuff. And I would argue that it's probably better to have some kind of protocol to put like several stuff in the up return payload rather than multiply them, which multiply all the junk, that has nothing to do with what we do with up return a bunch of time in the transaction. So I would prefer a solution that say, okay, if we want maybe put like several times the same protocol or a handful of different protocol in the up return, we can probably agree with each other and came up with like some kind of, best practice on how to say, like, okay, those like first 100 byte, it's, some SLP stuff, right? And then what is inside that, the next 100 byte goes to the node that processes SLP transaction. And then you can have like some extra data that say, okay, no, this is like a memo field, and what comes next is like, whatever tweet people want to post on memo. I would favor this kind of solution. I think it's better. And even if there is a good use case for it, we may look into increases the size of the up return. I think that would be a better direction than adding a bunch of up return in the transaction, just because when you add a bunch of up return, you had a bunch of junk in the transaction. Like it's adding a bunch of special output, but then you need to parse those output to verify that the up return, they are unspendable, so you don't add them to the UTXO set, and there's just like a bunch of extra logic that goes on with those output that are just like complication that stem from the fact that up return was not really intended to begin with. it's something like people kind of figure out that they could do after the fact. So I would rather like encapsulate all of it within the up return, like to just like contain the weirdness to what we already have. In term of coding for the node implementer, it's not that big. Having one larger up return is probably easier than coding the validation to have like like up to 3 but no more than 3, this kind of stuff. But either way, I don't think it's a huge challenge. the main stuff the main stuff I would like to add is that kind of like the size of script, we need to be careful because there is always a tragedy of the common problem here.
Definitely.
And so we need to make sure that there are good use cases and that the use cases, just because everything that we put on chain that way is something that everybody needs to pay for. And so we need to be mindful, obviously the people that are into SLP or into Memo or into whatever are going to say, well, like this is worth it, right? But they need to keep in mind that there are a bunch of people that do all their stuff with the chain. Mm-hmm. And those other people, they need to be convinced that this is worth for them to pay for it.
Definitely. I know I'm quick to point out that there's a Goldilocks zone with the op return data where too little is too limiting, and too much affects the cache core use case. And so I want to be careful. Like, my personal view on this is, boy, I could definitely see like 3 op returns would be great, as long as we maintain like all the other limitations as in terms of like the size of the transaction and the size of the op return overall in general. But there's a lot of different ways this could be and like our previous discussion on the number of opcodes in a script, I'm hoping that when the Filecoin network launches this next year, that someone, maybe myself, might implement a protocol that can use that op return to reference data in the IPFS network, and then offload. It's still immutable. It still retains a lot of the desirable effects of having something on chain without actually bloating the blockchain. So that's something I'm keeping an eye on as a possible off-chain solution. The problem really, or the reason why I think like more than one op return is valuable is because then you can layer protocols. So like say SLP, that takes the single op return, but then if you wanted to, one use case for multiple op returns would be easily expand the SLP protocol. But another common use case I see is like exchanges wanting to attach like a piece of information to a transaction, but if it's an SLP token, that op return's already taken. So that's a common use case where it's like, well, the op return's already taken by something that happened prior, and we need to add another piece of metadata to this transaction.
Yeah. So for that one specifically, I would encourage you to like essentially the idea that you have is that you want to have like several data carriers that are in the transaction, and you use the transaction format itself as as a separator between those different protocols. But I would encourage you, if that's possible, to make such a meta protocol, if you wish, that you can use in that you can use in op return, and that allow for payload for various protocols. And so it kind of become like the TCP/IP of op return or something like that. And if that protocol can be very simple, then various op return tools can be aware of it and extract the part that they're interested in.
Mark, did you have something you wanted to add?
Yes. Well, so I'll just offer a counterpoint to this idea. I think it's actually a nice idea if we'd had it sooner. The problem is SLP, for example, is a fixed rule set, and changing it would be like a hard fork on the SLP network, but it's not a hard fork where you have to upgrade the full nodes. You have to upgrade all the wallets instead because it's wallet validated. So changing SLP is almost harder in some ways than changing node consensus rules, strangely enough, even though it's like a softer protocol. So I don't think it's really possible to stuff the SLP version 1 into another protocol like that. It's kind of been fixed, and we're kind of stuck with it now. SLP version 2 could maybe do that. That would be kind of interesting. But yeah, right now everybody's building these protocols, and they're all just like, oh, I assume I have the op return in full, and that's how it is. And Yeah, I agree that it's not nice to use the transaction format as a separator. But on the other hand, it is. I think it is actually cheap in terms of the validation and the network load. There's an overhead that you have much. I guess probably 10 byte extra overhead because there's the amount, the script length thing, and the operator in itself. So that's 10 bytes. So having an extra 10 bytes for every operator you do is kind of annoying, but that's not very much on the other hand. And they don't go into the UTXO set, which is great. So that makes them really low load. And just as like a theoretical worry, what people could do instead of using operator, they could use other output types, which there are no limits on, to store data as unspendable outputs. Or they could make them spendable, I don't know. But I don't want it to be the case where people feel like they should put their protocol inside of like a bare multisig, because then they know their protocol can be used unlimited numbers of times in any transaction, right? Like right now there is sort of an incentive. I think it's stupid, but like nobody should do that. But it is sort of an incentive there. So I fully support the increase to 3. Just I wanted to say that, but and I think it's easy actually, because I think in ABC at least, the way the rule works is it counts the number of operators in the transaction, and then at the very end it's like, oh, is it more than 1? Okay, that's non-standard. I think that's so you could just change that 1 to a 3. You would have to change some of the implementation details so it knows if it's being activated yet or not. So because so this is the complicated part, Chris, is we would want that the network activates this at the same time, even though it's not a consensus rule, just for the sake of zeroconf to be robust. So that's actually where all the complication would be, in my opinion. Yeah.
Yep, agreed.
Any final comments on this discussion? Hearing none, we do not seem to have any questions from attendees. I've had no questions come up in the question box. I assume that we've covered pretty well everything that needs to be discussed for today's meeting. I want to take this opportunity to wish everyone the best of a holiday season. Starting here in Canada and around the world, people are taking some time off. So I hope you all get a chance to do that, spend some time with your families. And we'll look forward to seeing you guys in the new year. So thank you very much, and we'll get this video out as quick as we can.
Bye.
Thanks. Bye-bye.
Thanks, everybody.
Thank you.
Bye, everybody. Thanks.
Bye.